Fun fact, I usually draft our little videos here before I do them, so I actually know what I'm going to do in the video. So here you have a joke from Thursday that's pretty good. And here's the thing. It looks so good already, so I'm just going to talk you through what I did. I only got that far, and the rest of it we'll write by hand, but point is, I'm just going to talk you through this slide of notes right here. So we're talking about similarity. First thing with similarity that I want to talk about, remember dilations, our beautiful dilation project. Man, those were so good. A dilation is really just an enlargement or a reduction. This point here just might be really helpful for you on your homework. Just saying, basically, if you have a dilation, all of the points that you have dilated are collinear, meaning they're on the same line with the center of dilation. But let's be real. Enlargement, reduction, basically you're just multiplying everything by a scale factor, which we call k. So if k is bigger than 1, it's going to get bigger, and if k is less than 1, it's going to get smaller. And to find k, all you have to do is find the ratio of the side lengths. Ratio is a really fancy way to say division. So for an example, we have points A, B, and C here. That is what we call the pre-image, meaning, the original. And if my scale factor is 3, well, we're just going to multiply all of those points by 3. So -1 times 3 is -3, 2 times 3 is 6, 4 times 3 is 12, and so on and so forth. And that's how we get our image, is what we call it. So it's A prime, B prime, C prime. That's how we would call it. Yeah, that's dilations for you. So contrasting that, or more like comparing it to similarity, because they are very similar, one might say. Similarity, basically two figures are similar if all corresponding angles are congruent. Apparently I got an erased patch there. Congruent, and all side lengths are proportional. Here's what I mean by proportional. Wow, this is in red. I bet that was really important. Here's what I mean, is that first off, your similarity statement here is going to tell you which sides line up together. So AB goes with DE, BC with EF, and AC with DF. That's how we read the similarity statement. And so we could put our corresponding side lengths in ratios of each other, and they would all be the same. Because, hey, that ratio, what is that? Oh, the ratio is the scale factor. Oh my gosh. This all equals the scale factor. Look at that. So, for example, you got two triangles. You've been given a similarity statement, and you have to find the missing side length. Well, what I did, I saw AB matched up with DE, and I saw BC matched up with EF. And so I colored those in on the triangle just to see where my corresponding pieces were. And we have two different tactics where we can do this. I'm going to talk you through the proportions way first. So with proportions, I can set up the ratios of the corresponding side lengths. So for example, 8 over 12 equals 5 over x. And then we're just going to cross multiply it in order to solve. So cross multiply there, 8x equals 60, and divide it, and I get x equals 7.5 as my side length. The other way we could do it is we could find the scale factor, and so remember we find the scale factor through division, and so I just took 12 divided by 8, and we get 3/2 or 1.5. And now I'm going to multiply. If that's the scale factor, then that I can multiply any side length by that scale factor to get the new image. So I could take 1.5 times 5, and I get that 7.5. Please don't round your scale factor. You have to keep it exact. So that could look like a fraction if needed. So, like if you have 1/3, that's like a repeating decimal forever. Don't multiply it by 0.33. Just multiply it by 1/3. So that way you have a exact answer. honestly, that's going to take care of most of your assignment, for the record. There are a few other things I want to go over. Let's talk about mid-segments. Okay. So a mid-segment would be this guy right here because it's a segment and it hits the midpoints of both sides of that triangle. See how it cuts it in half? That's what those marks mean. So think about it this way. If let's say that this side is 10 and I want to know what that side is. Well, in reality here, I have two triangles. I have the small one and I have the big one. So let's say the small one was 3. Well, the big one, because it's just twice as long, it's 6. And the other one, let's say that was, I don't know, 2. Well, hey, there are twice as many on the other side, so that'd be 4. So that means if this one is 10, drawing not to scale, it's fine. Oh, well that means it's 20. Because really, all we're doing here is we're timesing it by 2. So we get 20 as our length. And so that's really basic with, numbers. This could also go into algebra. So let's say this could be like x minus 5, and this could be 5x plus 2. Well, here's what I know. I know that because this is a mid-segment triangle, that we just got to times that by 2 to get to the bigger length. So you go 2 times x minus 5 equals 5x plus 2. And then it's just solving the equation from there. Nothing too complicated. Just a game to get x by itself. 3x minus 2 is 12. X equals -4. Is a negative answer okay? A negative answer is okay as long as when you plug it in, you don't get negative length. So I could look on this one. -4 minus 5 is -9. Darkness. Negative length is not a thing, so this would actually have no solution. You're not going to have to worry about anything too complicated like that. As long as you know how to do this part, then you're going to be fine. Let's see, what else is on that assignment? Oh, let's remember proving. Proofs, your favorite thing? Remember, there are 3 similarity theorems. Angle, angle, meaning if two sets of corresponding angles are congruent, the figures are similar. Side, angle, side. I love me some sass. And side, side, side. Those are the only 3 proofs. And so if you have something like this, and let's call it J, K, L, M, N, and sure, I don't know. Which one would you use here? Well, I have 2 sides labeled, so more than likely it's not going to be angle, angle. I don't have 3 sides labeled, so it's not side, side, side. This would be side, angle, side. Well, I can check the scale factors between If you're wondering which sides match up with which, this would probably be an in red kind of thing. The longest side always matches up with the other longest side, and the smallest side always matches up with the other smallest side. So I know 24 goes with 8, 6 goes with 18. I see they have a scale factor of 3, so those are the same scale factor, which is good. And where's our angle? Oh, the vertical angle's right there. So this is side angle side, and I can say, if I'm to write this statement, I'm going to go here. I'm going to start at L, go down my longest side, and then down the edge. So that's triangle LKJ is similar. Let's see, down the longest side, down the other, triangle LMN. And that tells me which angles correspond with each other as well. If I had something maybe with like parallel lines, no sides are labeled, so that's a good hint. You're going to use angle-angle similarity. Well, with this, those are parallel, so I got some corresponding angles. And look, I got more corresponding angles. Hey, that's angle-angle similarity, so I could say triangle DEF is similar to triangle DGH by angle-angle similarity. That's pretty much the basics of what you need to know for similarity. Like, I know this unit seemed very difficult while you were in it. I'm hoping out of it, it's not that big of a deal. Well, there is one more thing I want to show you with right triangle similarity. Okay, let's do an example. Okay, let's say I got 10. I want to find that height. And let's say it's 16. And how about 24? Making up numbers, so we'll see. Okay, when you have a right triangle that has the height here, we call this the altitude of the triangle because it's like the height and it meets at a perpendicular angle, meaning 90 degrees. You have 3 sets of similar triangles here. We got the small, we got the medium, and then we got this big one here. Here's what I think is the easiest thing to do. I draw out the 3 different triangles. And you're just going to match them up by base, height, hypotenuse. And I just go triangle by triangle. I'm going to start small. I see the base is 10, the height we don't know, and the hypotenuse is 16. Moving to the medium, the base is x, the height I don't know, and the hypotenuse is 24. The big one, I see the base is 16, the height is 24, and the hypotenuse has something involving 10. We're just not going to worry about it. Here's your goal. You're just trying to get 2 triangles that have matched up side lengths. So here's what I see. I can use the small and that one, because if I just don't worry about that 16, look, I have 2 corresponding sets of side lengths in the same matched places. I could have used this one as well if I wanted to ignore this x over here. That's called a freedom of choice, and that's exciting. I'm going to use the big one, though, because I already circled it. So I could see x over 24 equals 10 over 16. And now I'm just going to cross multiply, so I get 16x equals 240. Divide both sides by 16. And you get some answer. I don't have a calculator next to me, but the point is we know how to do that. So, moral of the story, look for two triangles that have the same sides labeled. That's everything big from Unit 7.